Assalamualaikum warahmatullahi wabarakatuh, and hi to my respected lecturer Sir Ahmad Izzuddin bin Zainal Abidin. Right now, we would like to present about our project on COVID-19 cases analytic report based on our understanding on data science. Firstly, I would like to introduce my team members. First, SYAFIQ, who is me myself. Second, IRFAN. Then WAJDI. Lastly, ALMALIK. So, without any hesitation, let's start with WAJDI, who will talk on introduction.
Hi, my name is WAJDI, and now I'm going to be presenting to you about our project's introduction. So the purpose of this project report is to provide a detailed overview of the total number of Malaysians that have been affected by the COVID-19 virus, and also to provide a visualization of the positive COVID-19 cases so that we can have a much clearer view of the statistical numbers of the positive cases. So in the beginning of the project, we spent a lot of time finding some reliable sources of the data that we were searching for. After that, we also have to pre-process the data to sort out the number of positive cases, negative cases, and death due to COVID-19 virus. After the data pre-processing had been done, we came to a conclusion that the cases can be classified in a more focused classification, such as age classes and also COVID-19 clusters, which have contributed a lot to the rise in COVID-19 cases in our country. During the implementation phase, we utilized the RStudio software to write an R code in order to visualize the number of COVID-19 cases. In this case, we used the scatter plot for new cases, import cases, and also the active COVID-19 cases. During this phase, we also encountered some difficulties. We have to figure out how to eliminate the duplicate values from our raw data that we obtained. Other than that, we also face difficulties when classifying the cases into age classes such as child, adolescent, adult, and elderly. We also wanted to classify the cases into clusters such as import, religious community, workplace, and also education clusters. Moving on to the background, the threat of COVID-19 became more apparent in Malaysia when neighboring Singapore reported its first imported COVID-19 cases from Wuhan, China on January 23rd, 2020, which was also the first positive case in Singapore. 8 close contacts were identified in Johor, Malaysia, as a result of this first case in Singapore. Malaysia reported its first COVID-19 positive case on January 25, 2020, less than 48 hours after the case has been reported in Singapore. This was a case imported from Wuhan, China. Beginning with the first case, a total of 8 positive cases were reported within 6 days. All of these cases were imported from China. On February 3rd, 2020, the first Malaysian who tested positive for COVID-19 was reported. This person had a history of travelling to a neighbouring country for a business meeting, which also attended by a Chinese delegation. Overall reported cases in Malaysia can be divided into 3 waves as of March 31st, 2020. By February 27th, 2020, the first wave had been successfully handled, with all the 22 previously reported cases being discharged from hospital. The majority of cases reported in the first wave were imported from China, as were their contacts. Only 2 cases were discovered to be the results of local transmission. And then, for our forecasting goal, we split the data into test data, which is 20%, and also the trained data, which is 80%. A forecasting model was considered and used for the dataset to forecast and the error of the model is evaluated. Model chosen is ARIMA, which is achieved by combining the auto-regression AR and moving average MA for the next year. For this case, we choose 2020. ARIMA model tend to perform greatly and is best used for COVID case forecasting. Auto-correction function ACF and partial auto-correlation function PCAF are merged and serve as the ARIMA model used to forecast the case number. So that is all from me. Thank you.
For the data description, the group was recently surprised by an unexpected global outbreak that began in Wuhan, China. A virus known as COVID-19, also known as the coronavirus, infected the world. From 25 January 2020 to 34 November 2021, we tracked the number of Malaysians who are affected with the COVID-19 pandemic. We gathered about 2,644 data in the form of an Excel spreadsheet that we found on GitHub. For the data explanation, there are 4 attributes in the data sets. They are date, where we use 1200 hours format on the date. New cases stands for the case report in the 24th since the last report. Cases import stands for import cases reported in 24th since the last report. Lastly, cases active stands for individual that had been affected by the COVID-19. Next, for data quality limitation, we have a big amount of data with 2,644 records in the datasheet. Having too much data can result in redundancy, which can compromise the accuracy of the outcome. Because the data will be trained and tested, it does not guarantee that the final result will be accurate. So, as previously said, we are still able to handle all the data accurately since we focus more on the features that we require to complete the project by limitation the number of attributes in the datasets. Despite the challenge, we can determine the new cases of the people who had affected in Malaysia, new cases people that had affected overseas, and the number of cases affected in Malaysia.
Thank you, Irfan. Before we start further data preparation, we must first analyze that there are no duplicate values or NA values. This is because we want to avoid any effect on performance and accuracy to the data plotting later on. As shown on the slide, there are no duplicate values found in the datasheet row. Since we only use 3 types of data, which are cases new, cases import, and cases active, we only modify the NA values from the datasheet. So the data that we are using are good, as there are no NA values from the datasheet. Next, we will show the data plotting based on our variables using ggplot2 library, as it is easier to handle with the date format data. If we are using only built-in plot functions, we need to change the date data type from character to numeric, as numeric is needed for plotting. However, as we change the data type to numeric, the value changed to NA, so it is a problem for us. Thus, we stick to using the ggplot2 library function. Then, here are the graphs. We only use 2 graphs, which are scatter plots and correlation plot. Now we will proceed with ALMALIK. Thank you.
So I will present about the solution. So the first part of the solution, we did exploratory analysis. So we just plot the graph of no COVID cases over the date in the year 2020, and then we perform data normalization. This is to calculate the moving average to be used for detrending purposes. So the detrending work and process start with shifting the value into time series for forecasting. The purpose of detrending is to identify cyclical and other patterns. Detrending shows different aspect of time series data by removing deterministic and stochastic trend. And then we implement the ACF auto-correction function and PACF partial auto-correction function. ACF is to observe the correlation between the spot before and the current spot. Meanwhile, PACF is used to remove the influence of the day before yesterday to get the observation of the correlation between 2 spots, given that we consider both observation to be correlated to other time spots as well. ACF is basically the moving average of the graph, and PACF is the auto regression. So then we combine both of the auto regression and moving average, and we get the ARIMA forecasting for the next year. So in here we plot the ARIMA forecasting for next year. So we get that the number of cases is expected to be uptrend. It is expected to increase, and the confidence interval is like the highest or the lowest possible number of cases demonstrated in the gray area. So, and then what the finding we get that if we compare the forecasting and the actual data in the year 2021, we can see that the number of cases does rise above 3,000, indicating that the forecasting is valid. But then, we need to consider that the forecasting does not forecast for detrending in long-term projection. As we can see, after the number of cases hit 5,000 cases a day, it goes down. The number of cases decrease. The reason for this is because the forecasting is primarily dependent on the trend of graph, the moving average and the regression of the graph, and it doesn't take important variables into account, such as the forecasting of such as the vaccination rate, movement restriction, and reopening of economy, because this variable does affect the number of daily cases. So we can only use the time series forecasting for short-term forecasting, and the 95 confidence interval should be observed properly and taken seriously, because the daily cases can increase suddenly and decrease suddenly. So the forecasting shall be updated by time, more or less about 1 or 2 months, because we need to get the new trend, since the forecasting doesn't take those important variables into account. So for long-term forecasting, we need to combine the ARIMA forecasting and also include the parameters like vaccination rate, movement restriction, and other intelligence related to daily cases projection to forecast for long term. So that is all for solution and finding.
In conclusion, the current study has able to give a true analysis of nation's current status about COVID-19 cases. The findings imply that nation has serious cases where it peaks in the middle of the pandemic. Somehow, segments of the community may benefit from target health education program aimed at improving COVID-19 understanding and practice. There is no specific treatment for COVID-19 at this time, so many clinic trials are being conducted through the world to develop COVID-19 treatments and vaccines. So at the same time, the knowledge learned from the worldwide response to COVID-19 should encourage countries around the world to be better prepared for the future disease outbreak and pandemic. As a result, we can only utilize time series forecasting for short-term forecasting, and the 95% confidence interval must be adequately observed. So the forecasting will be updated through time, so that if pattern of the cases change, the forecasting will alter as well. This is because daily cases are affected by vaccine rate. Other than that is the factors. So that's all from us. Thank you.